Alrighty, so welcome to our very first class together. My name is just Peter, and I'll be your tutor for the next 12 weeks. Okay, so we're just gonna go straight into our first problem, and it looks as follows. We've got 5Q, this is part A of question 1 here. Oh, you don't see that? Let me try to bring it up on the screen, of course. So we'll just wait until it loads up. So I'll just write out the question while we wait for this to load. Over p plus 2 divide by 1 over p plus 2 is equal to 20. Alrighty, so here's our very first problem for the semester. So we've got a fraction here, 5q over p plus 2, which is divided by another fraction, 1 over p plus 2 is equal to 20. And our job is to solve for this problem. Okay, so whenever I have a fraction divided by another fraction, I often convert this into a multiplication problem. So how do I do that? And I'll wait until you sort of catch up writing all this. I'll just maybe pause a little bit. But basically, I'm going to copy this first fraction, and actually I can probably do it now, over p plus 2. I'm going to convert this division sign to a multiplication sign, and I'm going to convert this to a multiplication problem by basically performing the reciprocal on this second fraction. So what does reciprocal mean? It means the top becomes the bottom and the bottom becomes the top. Basically, you're just going to flip it, right? So this bottom becomes the top, divide by this top becomes the bottom is equal to 20. And when it is a multiplication problem, it's more easier to solve because you just got to multiply the top, divide by the multiplication of the bottom is equal to 20. In this case, we don't even have to do that because there's some cancelling we can do. So we've got p plus 2 on the top, which you can cancel with the p plus 2 at the bottom, leaving just whatever is remaining. So we've got 5q over 1 equals 20, or essentially just 5q is equal to 20. Okay. So for QA, I do like starting from the ground up. So I'm assuming you guys don't know how to actually get 5 to the other side. So the way we can do that is we can, one, do this the formal way. We can just say divide both sides, where BS stands for both sides, divide by 5. So what does that mean? It means on this side, I divide by 5, 5q divide by 5, and on this side, I divide by 5, 20 divide by 5. And the good thing about doing this the formal way, mechanically you can see what's going on. 5 and 5 you can cancel out. So 5 divided by 5 is just 1, or 1q, or just q. And 20 divided by 5 is just 4. Okay, so that's the formal way. We can also use the informal way, which is just basically another way to describe the formal way. So for example, to get 5 to the other side, I often say this. I say I just got to do the opposite of whatever 5 is currently doing. At the moment, 5 is being multiplied to q, so the opposite of multiplication is just division, right? So again, we just doing it here. Q is equal to 20. To bring 5 to the other side, I got to divide 20 by 5, as so. Right, and that will get you, of course, the same answer as 4. So I often interchange between the informal way and the formal way. They're basically the same ways, but just a different way to describe it. Okay, that's our very first problem. Let's keep on going, and we've got our second problem here. This is part B. We've got x minus 2 squared is equal to 4. Okay, so what do we have here? We want to solve for this x. So there is a longer way to do this. I'm going to show you a shortcut way. Essentially, we still want to get x by itself, but the thing is, we've got to treat this like a Lego block, where we can't just bring x by itself and bring everything else to the other side just like that. We've got to start from the outside going in. So you just imagine x is like a center block inside this big construction, and you can't just have an invisible hand and just reach in and pull it out, right? So you got to deconstruct it from the outside, and then eventually you reach x. Okay, so we're going to move the most furthest piece first from the outside going in. The most furthest piece here is this square. Okay, so when you move it to the other side of the equal sign, you kind of follow the same methodology as I described before, based on the informal methods. Just basically, whenever it goes to the other side of the equal sign, it does the opposite of whatever it's currently doing. So who can tell me, what's the opposite of square?
Square root.
Square root. Okay, so that's what we're going to do. We can keep the brackets here, or you can remove it, but I'll just keep it there. So when you move to the other side, it becomes a square root. So the square root of 4. Right? But recall that whenever we do square roots, it's always followed by a plus or minus, meaning there's two answers here when we handle it in a square, right? And just to elaborate more about that, if we've got -2 square, -2 square is +4, but we can also get +4 if it was +2 square, right? +2 square is also +4. So +4, when you've got a square situation happening, can be derived from a negative answer or positive answer. So to appreciate both of these answers, we have to put a plus minus when we do a square root 4. Okay, so we can get rid of the brackets and we can simplify square root 4. So x minus 2 is equal to plus or minus the square root of 4. If you don't know it, pop your calculator in. Otherwise, square root 4 is just a +2. Okay, so how do we get x by itself? We've got to move this -2 to the other side. X is equal to, when we move -2 to the other side, it becomes the opposite of whatever it's currently doing. Opposite of -2 is of course +2 plus or minus 2. Okay, so we're getting closer here. X is equal to, so there's two answers here, plus and minus. +2 plus 2 is +4, comma, and this is the second answer. +2 minus 2 is just 0. So those are your two answers here. X equals 4 and x is equal to 0. And you know, you can easily validate this answer as well. So you can put 4 all the way back up here as your x. 4 minus 2 is 2, 2 squared is 4. Or you can put 0 all the way back into x here. 0 minus 2 is -2, -2 squared is 4. So you can see two answers are happening there. Okay, let's do another problem. Here we go, turning over in 3, 2, 1, 0. So we got 3y squared plus 4y minus 3 is equal to 6y plus 9. Okay, so what do we do from here? So we've got to solve for this y unknown variable. We've got some terms on this side, we've got some terms on this side. Let's bring them together on the same side of the equal sign and see what we can simplify. So I'm going to move 6y to the other side, and I'm going to move +9 to the other side. So let's do that. Let's write this as it is first. We've got 3y squared plus, this is part C by the way, 3y squared plus 4y minus 3. Okay, so when I bring this 6y to the other side, it does the opposite of whatever it's currently doing. At the moment, it's just being a positive number. So when you bring a positive number to the other side, it becomes a negative number. And over here, we're going to bring +9 to the other side. So +9 to the other side becomes a -9. And since there's nothing left on this side, I'm just going to say equals to 0. Okay, we've got some like terms to simplify. 3y squared doesn't simplify with anything here, so we're going to leave it as it is. 4y can simplify with -6y. So +4 plus 6 is, and if you're unsure with negative numbers, you know, there's no shame, just use your calculator. 4 minus 6 will give you a -2y. And then we've got -3, which can be simplified with -9. So -3 minus 9, again, use your calculator if you want to be sure about it. But, you know, take the opportunity, if you're not sure about negative numbers, take it as an opportunity to learn about negative numbers, right? Not something I can show now, but if you would like, you know, ask me during our, after our class, and I'll be happy to show you. Okay, well, you can just Google negative timelines or summing negative numbers, and you should see an example of that. Anyways, negative, what are we up to? Where are we up to? Equals 0. Okay. So we haven't yet got there, but we are getting closer. So you may recall that this function that I've just generated is actually actually has a very special term, right? So who can tell me, what is this function known as? And it starts with Q. Yeah, it's just a quadratic. So we're going to use the quadratic formula to solve for this. It's probably the most systematic way to do that. But before we do that, the general term of a quadratic looks as follows. We've got ax squared plus bx plus c is equal to 0. Something that you may recall back in your high school, primary school days. Okay, so we need the coefficients of a, b, and c. So what's a? Well, a is the number in front of x squared. X squared is equivalent to y squared. So a is the number 3. B is the number 2 or negative 2 in front of y. And c is negative 12. So we're going to substitute a, b, and c into our quadratic formula. Our quadratic formula looks something like this. Not something that you have to memorize, but you do it enough and you kind of put it into memory. Something like this. But this is definitely on your formula sheet. Okay, so we're going to plug in a, b, and c into our quadratic formula to solve for our y unknown variable. So y is equal to, so negative. So what's b? B is negative 2. So we've got a negative, double negative situation happening. We've got to appreciate that a bit later. Plus minus, so again there's two answers. The square root of b squared. B squared is negative 2 squared. Multiplied by 4 times, not multiply, where am I getting multiplication from? Minus, yeah? Minus 4 times, just forgot the minus. Minus 4 times a is 3. Multiplied by c is negative 12. Okay, divide everything up there by 2 times a. 2 times a is your number 3. So if you have your calculator here, do give this a shot because you just want to make sure that you're doing the right numbers and plugging them in correctly into the calculator. But this negative here basically becomes double negative, so it becomes a positive 2 plus this answer divided by 6. That's your first answer. Then you got positive 2 minus this answer divided by 6. So you got two answers here, and if you've done things correctly, you should get something similar to this, 2.36 and negative 1.69. So those are your two answers for y. Okay, so if you don't have a calculator, do make sure you go home, give it a go, and see if you get the same answer. Because often or not, in an exam or in a test, I'll see the right numbers, but I see the wrong final answer, which would suggest, of course, a calculator mistake. Okay, got a couple more problems to do. Here we go. Ready to move on? Anyone need any paper? Need paper? Paper? Okay. It's alright. Welcome. Question 3, we've got P, Q, 1.5 to the power 1.5 and P squared. Okay, so what's our job here? Our job is to solve, to simplify for this problem. So we want to simplify. So just notice that each of these 4 terms are being multiplied together, right? So whenever I see something like this, I know I'm probably going to be using one of these indices rules. There's several of them, but I'm just going to introduce the relevant one for this problem, and it looks as follows. When you got x to the power a multiplied by x to the power b, and the bases are the same. So these x's are your bases. They're the same, right? You can simplify this by adding the powers, a and b. So this can be rewritten or simplified to x to the power a plus b. A plus b, right? So what do we do here? Well, notice we've got bases of p and p squared, which I know they're not right next to each other, but they are being multiplied together, right? Or implied to be. We can simplify them by just adding the powers. So this becomes p, and this p by itself is actually to the power of 1 here, right? So we can simplify that. It says 1 plus 2. So I'm just going to write it in full because it's our first time doing it. 1 plus 2. And then we can do a similar thing with this q and this q. So they're both the same basis. We can simplify them by adding the power. So this is q to the power 1. 1 plus 1.5. So q 1 plus 1.5. Okay, so this then further simplifies to p, 1 plus 2 is 3, q, 1 plus 1.5 is 2.5. And there's your answer. Okay, let's keep on going. Too quick, we okay? Alright. We got part B here. We got 15e to the power of alpha, e to the power of beta divided by 3e to the power of 3 is equal to. Okay. So where do we go from here? We want to simplify. Okay. So what's the first thing we can simplify? Well, I can see 15 can go and divide by 3 and give me a number, right? So what's 15 divided by 3? We know? Yeah, it's just 5? Okay, so 5 is equal to E alpha E beta divided by E to the power 3. Okay, so where do we go from here? This next move is actually a very common problem, right? Or common sort of transposition, right? And it's basically, we're going to be moving this E to the power 3 upstairs. So we're going to move it upstairs. So how do we move something at the bottom upstairs? We're going to be using this other index rule, which reads something similar to this. On your formula sheet, they may be using different notations, but something like this, x to the power a, for example. So we can rewrite this by bringing x to the power a upstairs, right? Upstairs meaning moving up there, right? By putting a negative in front of the power as x to the power negative a. So that's how I essentially remember it. If I want to bring something upstairs, I'm going to put a negative in front of the power. So similar with this, right? I'm going to move e to the power 3 upstairs. So let's write what we have by putting a negative in front of the power. So bringing it upstairs becomes e negative 3. And you'll be surprised on how often you actually use this. So you don't have to use it a few times to have that ingrained in your memory as a tool to transpose something, right? Okay. Who wants to suggest to me, is there a way we can simplify this even further now? How? Plus the power, because, very good, these e terms are all multiplied together. They have the same basis, so we can add these powers. So we can 5e alpha plus beta plus negative 3. Okay, I've put the plus there just to illustrate how we're just adding it, but of course when you guys do it, you don't even have to include the plus. You can just go minus 3. Okay. Let's do our application problem. Any questions here? We okay? Yeah. Okay, this is question 1. This is our problems where we got some words to our problem. So here we've got a demand function, reads as follows. Okay, so what do we want to do here? We want to, for part A, interpret the slope and interpret the intercept. Okay, how do we go about doing that? You may recall a general form of an equation that looks as follows. Y is equal to mx plus c. So just a general form of an equation, of a linear equation to be precise. What's m? M is your slope. What's c? C is your intercept. Okay, so from this equation, what is your intercept? Well, this is your intercept. And this negative 0.5 is your slope. Okay, let's interpret the intercept first. Okay, so what is the intercept? Well, there's a general template for the intercept. You just say when q equals 0, p is equal to, well, whatever's left over. If that's 0, the only thing that's left over is 100. That's just a template version, but you can put a story behind this, right? You can say when 0 quantities are sold of whatever this quantity is, right? The price charged in the market or the prevailing price is just $100. That's just putting a story there. Okay. Let's keep on going. Let's interpret the slope. Okay, so there's also a template version we can employ here, and it reads something like this. So for every additional q, for every, let's say 1 unit increase in q, and if you've done any basic economic subject before, you would have seen this definition. For every 1 unit increase in q, this price, right? Price will either increase or decrease. Whether it's increasing or decreasing will depend on the slope sign, right? So here, the slope is negative, right? So since it's negative, I'm gonna use the word decrease. So you can cross out increase. So it will decrease by 0.5 units. Okay, so this is again just a very templatey version to use, but you can put a story here, right? So let's assume the unit of interest is dollars, right? So you can say for every, this will be for quantity. So for every, that's not dollars obviously, we're going to put as, it could be depending on the story, but generally it's like one stuff of Q, right? So for every 1 unit increase in quantity, price will decrease by $0.5, right? But sometimes the units could be $1,000, could be more than that. We're not sure. So this is just a template version. Okay, that's part A done. Let's do part B. So part B says when P is equal to $3.60, find Q. Okay, so let's do that. So we got our demand function. P is now 3.6. So let's plug in what we know. 3.6 is equal to 100 minus 0.5 Q. So our job is to solve for this Q. So again, we're going to treat this like a Lego block. You don't want to start with Q straight away. You got to deconstruct it from the outside going in. So the furthest outside piece is this 100. We're going to move it to the other side. When you move it to the other side, it does the opposite of whatever it's currently doing. At the moment, it's just being a positive 100. So positive 100 over to the other side becomes a negative 100 as so. There we are. Okay. 3.6 minus 100, we know that to be just negative 96.4, which is equal to, well, we'll just leave the other side as it is, negative 0.5 Q. Okay, we've got double negatives on both sides. Well, we've got 2 negatives here. We can just cancel out, right? Leaving just 96.4 equals to 0.5 Q. We can bring 0.5 Q to the other side by doing the opposite of whatever it's currently doing. At the moment, it's just being a multiplied to Q, right? So to bring it to the other side, you do the opposite of multiplication. So you go 96.4 divide by 0.5 and you're going to get an answer of 192.8. Okay, so there's your answer for Q when price is 3.6. But how do we, we can validate this answer further so we can walk away and know that this question was done correctly. So how do we do that? All I got to do is plug in this answer that I just solved as my Q function here, pop it there as my Q, redo this calculation, and assuming no rounding issues, you should get exactly 3.6. Alright, so this is the beauty of doing quantitative subjects. You have the ability for most of these questions to validate your answer, to walk away and say, there's no reason why I should not be getting 100% on this question. Okay, we got another one, so I'm just going to move on here. Ready? 3, 2, 1. Part C. So it says here, our job is to solve for Q. Basically to get Q by itself, right? So we've got this function here, 100 minus 0.5 Q, our demand function, and we want to get Q by itself. Okay. So how do we do that? Again, we're going to move everything to the other side of the equal sign, leaving Q on its own. So again, we start from the furthest out piece, that would be this 100. Let's bring it to the other side. So we've got P minus 100 is equal to negative 0.5 Q. Okay, now we want to get this negative 0.5 to the other side. Again, you do the opposite of whatever it's currently doing. At the moment, it's just being multiplied to this Q, right? It's just being multiplied to this Q. So when you bring it to the other side, the opposite of multiplication is just divide. Right? Or you can do this the formal way. You can say divide both sides by negative 0.5, whichever makes sense. Okay, so let's divide both sides by negative 0.5. Here's the thing, both of these terms are actually divided by negative 0.5, not just one of them. Both of them have to be divided, right? So I'm going to divide each one of these by negative 0.5. Right? So we've got P divided by negative 0.5 minus 100 divided by negative 0.5 is equal to Q. Okay, so how do we simplify this even further? Well, let me do a quick exercise with you. Let's say, who can tell me, what's 2 divided by 0.5? What's 2 divided by 0.5? 4. What's 3 divided by 0.5? 6. What's 4 divided by 0.5? 8. Okay, there's a pattern going on here, and this is basically it. Whenever you divide a number by 0.5, you're just basically multiplying the top number by 2, or you're doubling it. So 2 divided by 0.5, 4. Double of 3 is 6. Double of 4 is 8. Right? So that happens whenever you divide a number by 0.5. And similar here, P divided by 0.5, you just double P. Double P is 2P, but there's a negative that follows here, so this becomes negative 2P. Just like that. Okay, similar here. Well, negatives and negatives cancel. So what's 100? This is just basically positive 100 divided by 0.5. Or double 100 is, and there's your equation solved for Q. Okay. We've got one more application to do, but application question, but I'm going to let you guys to do this, but we'll set it up together. So here we go. Ready, steady. I'll just drink some tea while I wait. Here we go. 3, 2, 1, action. Okay, so I'm just reading the story. It reads, a canteen is basically it's another Australian term is called a tuck shop, but basically it's a place where they sell food, right? So a canteen has fixed costs of $1,500 per week. So there's a fixed cost of $1,500 per week. Meals cost $5 each, so cost per meal is $5. And it also says here, and are sold at a fixed price of $9 each. So sold at $9 each. So sold at $9 each. So there's our story. We've got a fixed cost of $1,500. Cost per meal is $5, and it's sold at this canteen at $9 each. So for part A, our job is to generate both a total revenue and total cost curve, or total cost function, I should say. Okay. So let's do the total cost first, right? Total cost function. Whenever I see a fixed cost here, it does cue me that I'm probably going to be looking at a general form of a total cost function. So who can tell me what total cost function? What's the equation for total cost? Yeah, variable cost plus fixed cost, right? I'm just going to put fixed cost first. Fixed cost plus variable cost. Okay. So what's our fixed cost? Our fixed cost is 1,500, and we're only calculating total cost per week here. So this is per week numbers. Plus, okay, what's a variable cost? Well, to produce one meal, it's going to cost us $5 each time. Okay, so we need a term that describes that relationship, that variable relationship. Okay, so we need to have some sort of variable. Before we do that, we need some sort of variable to represent number of meals, right? So I'm going to say here, let Q represent number of meals. You can say number of meals sold or number of meals, let's say number of meals sold. Okay, so for every meal sold, I'm going to incur a cost of $5. How do I represent that in a relationship? 5 times Q. If I sell one meal, the cost is $5, or the variable cost is $5. If I sell 2 meals, the variable cost is $10. If I sell 3 meals, the variable cost is $15. What's my total cost? $15 plus 1,500 gives you the total cost per week. So there's our total cost function for this canteen. We also need to generate a total revenue function. Okay, so if I've given price, who can tell me what's the general equation for total revenue if I'm given price? Yeah, price times quantity. So again, a very common equation that we'll be utilizing to work out total revenue. This will not be the first time you see this equation for total revenue. Okay, it will get more complicated than this as time goes by, but you know, it's good to start with a simple problem first. But what do I mean by that? I mean, you're still dealing with a simple equation for total revenue, but sometimes there's an equation underlining price, right? Or sometimes there's an equation underlining quantity. So it does get more complicated than this, but that's the general equation is still pretty much the same. Okay, so total revenue is equal to, what's your price? Your price is $9 sold multiplied by Q. So it depended on how much meals you sell. That's your total revenue function. Okay, for part B, C, and D, or whatever, how many parts left here, I'm going to get you guys to work it out whilst I walk around, but I'm going to set you up first. So for this part B, it says, if total cost is equal to $2,300 per week, find quantity. That's your job. Part C, if total revenue is equal to 3,780, find Q. Okay, and part D, if quantity is equal to 500, find profit. So this is my symbol for profit, something that looks like a pi sign, and that's my profit symbol. So you might want to ask yourself this question. If I have total cost and I have total revenue, can I calculate profit? Okay, and one more thing I'm going to add here before I let you guys do this on your own. B, C, and D are all standalone questions. You treat B as a standalone question, a unique answer. You treat B as a unique standalone question, and you treat D as a standard unique question. Okay, I'm not going to go through the solutions of this, but my aim is to visit each one of you guys and just double check that you're doing things correctly. So this is our feedback time. So if you have any questions or if you have any concerns or you want me to go through anything, this is the opportunity to ask me. So this is pretty much it for us in terms of a formal setting. I'm going to let you guys do this. Let me know if you've got any issues and we'll go from there.